Welcome to the Explainer. I am so pumped to get into this with you today. We're looking at a massive, fundamental shift in the 2026 AI landscape, the rise of reasoning models. We are officially moving way past the days of models that just spit out the very first words that pop into their heads. We're entering this whole new era where the AI actually takes the time to genuinely deliberate, debate with itself, and, well, think before it speaks. If you're building AI systems right now, this is literally the new brain of your operation. And trust me, it changes absolutely everything.
But, before we talk about the shiny new solution, we kind of have to understand the problem we're solving. Think about this for a second. How do you debug a black box? Historically, builders have suffered from this massive AI observability gap. You'd send a prompt to a language model, wait a couple of seconds, and get your answer. But if that answer was totally wrong, or even worse, if an autonomous agent just made a spectacularly bad decision halfway through a task, you had absolutely no idea why. None. You were just left guessing. You saw the input, you saw the output, but that internal logic was entirely hidden from you.
Well, today, we're going to fix that. Here is our roadmap for the Explainer. 1. The reasoning revolution. 2. Fake versus genuine reasoning. 3. The bimodal economy. 4. Visible versus hidden thinking. And 5. Exactly when to use these powerful new tools. Okay, let's dive right into this. Section 1. The reasoning revolution and the paradigm shift.
So what actually changed to make these new models so different? It all comes down to how they're trained. Before 2024, getting an AI to reason was, well, basically just a clever prompt engineering trick. You'd type, "Let's think step by step" at the end of your prompt, and you'd coax the model into generating a chain of thought. But it wasn't actually trained to deliberate, right? It was just trained to be a good conversationalist. Post-2025, with massive breakthroughs like DeepSeek R1, the game completely changed. These newer models are trained using reinforcement learning. They are specifically rewarded for producing long, useful chains of thought and actually landing on the correct final answer. They literally learn to simulate a multi-perspective debate, catch their own errors, and sometimes generate thousands of tokens of internal thought before they give you even a single sentence in reply.
Moving on to Section 2, fake versus genuine reasoning and understanding faithfulness. Because just because a model spits out a nice little bulleted list of steps doesn't mean it's actually using them to think. The science behind this is actually fascinating. Researchers in 2025 and 2026 tested this concept called faithfulness. And they did this by basically playing a game of Jenga with the AI's logic. They'd pull out single steps from a model's chain of thought just to see if it changed the final answer. They called this metric step necessity, and what they found was crazy. For reasoning-trained models, removing a step changed the answer 30 to 90% of the time. That means the steps are load-bearing. They actually matter. But for general, conversational models that were just prompted to think step by step, the necessity was below 17%. The steps weren't doing any heavy lifting. They were literally just there for show. This leads us to 3 distinct modes you've got to watch out for as a builder. First is genuine reasoning. This is what we want. The steps are load-bearing, and you can absolutely trust that the model's output genuinely reflects its internal logic. The second mode is scaffolding. This is where the chain of thought helps the model's overall accuracy, sure, but the specific steps themselves are somewhat interchangeable. In the third mode, decoration. This is purely a performative trace. The model already intuitively guessed the answer, and it's just generating a post hoc rationalization because, well, that's what showing your work looks like to us humans. As a builder, you absolutely need genuine reasoning if you're ever going to rely on that trace.
And relying on that trace definitely comes at a price. Section 3, the bimodal economy and the harsh realities of cost and latency.
If you treat a reasoning model like an everyday conversational model, it is the absolute fastest way to completely burn through your budget. To understand why, let's look at the exact same hard math problem run through Claude Sonnet 4.6. First, without extended thinking, and then with it turned on. Without thinking, it spits out 200 tokens, takes about 2 seconds, and costs a tiny fraction of a penny. Awesome. But when you turn extended thinking on, the model might sit there and generate 8,000 thinking tokens before it even starts writing your 200 token response. The latency suddenly jumps to 30 seconds, and the cost jumps to 12 cents.
Think about that for a second. That is a 40x cost ratio. 40 times more expensive and 15 times slower. This right here is the bimodal economy. We now live in a world where you have cheap, incredibly fast workhorse models on one side and expensive, slow, highly analytical reasoning models on the other. The real discipline of the modern AI builder is knowing exactly when to use which. Which leads us perfectly into Section 4, visible versus hidden thinking. the observability superpower.
Because if you're going to pay that 40x premium, you really need to know what you're getting. This is probably the most crucial choice you're going to make. Visible chain of thought, or COAT, is when the provider gives you the model's internal reasoning trace right alongside the final answer. Think of this as the AI equivalent of a traditional software stack trace. If something breaks, you can look inside, read the model's thoughts, and actually debug it. You can audit it. You can even route your logic based on it. Hidden chain of thought is the exact opposite. The model thinks deeply on the provider's server, but you only ever get to see the final answer. You get the quality boost for sure, but you stay entirely in the dark about how the model actually got there.
When we map out the mid-2026 landscape, a really clear pattern emerges. Open-weight models are absolutely dominating this space. DeepSeek R1 and v3.2 are fantastic for high-volume, cost-efficient reasoning. GLM 5.1 is absolutely crushing it for software engineering agents. KimiKey 2.6 is a huge favorite for long-horizon agentic tasks, and Qwen 3.6 leads the pack in multilingual reasoning. And get this, almost all of these, plus Anthropic's Claude, offer visible traces. The big exception here is OpenAI's GPT 5.4 thinking, which remains closed and hidden. Now, it offers absolute frontier capability, no doubt, but for builders trying to construct complex agentic systems, visibility is rapidly becoming the default requirement. You just simply have to be able to see the system's logic if you want to maintain it.
All right, so we know what they are, we know they're expensive, and we know we want visibility. Let's hit Section 5, when to use reasoning and strategic deployment. When do we actually pull this very expensive lever? I want you to literally burn this diagnostic question into your memory. Would a careful human take a few minutes to think before answering this? If the answer is yes, then a reasoning model will probably help you out. If the answer is no, you are just throwing away money and latency. This is the ultimate heuristic that the best production teams are using today.
So here is exactly where reasoning models absolutely earn their high cost. Deploy them on multi-step math or complex scientific problems. Use them for intense coding tasks where the model really needs to understand an entire codebase, anticipate weird bugs, and plan out changes. They are incredibly good for multi-step agent planning, situations where an agent has to pick a tool, evaluate the result, and maybe even correct course if the tool completely fails. They also excel at critical analysis and verification, like reading through a document to spot logical fallacies. And finally, use them for ambiguous problems. Stuff like high-level architectural decisions or considering multiple perspectives before committing is super valuable.
But on the flip side, the most crucial thing is knowing when to hold back. Please do not use reasoning models for simple conversational responses. They will literally overthink a casual hello and generate 5,000 tokens of totally unnecessary deliberation. It's ridiculous. Keep them far away from high-throughput, simple classification tasks. The cost just isn't justified at all. Avoid them in latency-critical interactive apps, like live voice or chat interfaces. Your users are not going to wait 30 seconds for a text reply. And simply put, if a fast, cheap, instruction-tuned model already handles the task perfectly well, sticking with it is the smartest engineering decision you can make.
So, I want to leave you with this final thought as you go out and build the next generation of AI systems. If your complex, multi-step agentic system makes a catastrophic, totally unexpected decision at step 7, are you going to be left staring at a black box, completely guessing what went wrong? Or will you have built your system on a visible reasoning model, allowing you to literally read the AI's mind, debug its logic, and fix the flow? The tools for genuine AI observability are finally here. The choice of how to build with them is now completely up to you. Thanks so much for joining me on this explainer, and hey, happy building!